So thanks everyone for joining. This is the inaugural Azure Enablement series session for what we're going to be doing within our team to be able to bring more different content to our customers, all from our app innovation as well as our infrastructure technical specialists within Microsoft and within the West Midwest region. And so my name is Kevin Kraus. I am a principal Azure technical specialist within the West Midwest region, and you folks that are on the call are customers within that region. And we have sent this out, of course, to be able to contact and better understand some of the requirements that you guys might need, that this particular pattern might be able to help accelerate your move to the cloud. So I like to do a lot more of the demos and stuff. So we're going to dive into some of the details about the initiative itself. We also have some folks from the product group that are on the call. We have Adrian, Nish, as well as John is on the call. So we can also field a lot of different deep technical questions, as well as some of the different reasons for the direction that this pattern went in. And those different decision folks can be able to help with those questions. But I'm going to get into the details about the initiative. We'll then jump into the first pattern, which is this reliable web app pattern. And then we'll dive deeper into the technical side of it, and we'll do demos around what exactly the pattern has and is part of. We're going to talk about some of the different patterns that are part of that repository that we're going to show you, and then of course we'll finalize with some Q&A for folks who want to be able to ask some more detailed questions. So with that, let's go ahead and start. So first thing we're going to deep dive in is to the enterprise app patterns. So the enterprise app patterns initiative really kind of aims to address the key feedback that we as Microsoft continue to hear from our enterprise customers, like yourselves on the call, feedback that says that customers, that they need better end-to-end application guidance around architecture. They need to be able to reduce time for their proof of concepts when they're trying to get applications out to the cloud, as well as the ability to kind of accelerate that modernization of the app estate that is on-prem out to Azure. And so enterprise app patterns, they include basically packaged, reusable starting points that include detailed guidance, reference implementations, deployable stacks, as well as automation for things like multiple environment configurations. We've included things like simulations that our customers can use for demonstrating, kind of learning those complex concepts, the design patterns that are included, as well as best practices around those enterprise applications. And these concepts are things such as scaling, reliability patterns, caching and load leveling patterns, as well as identity. We got configuration as well as secret management as well. Then each one of these different patterns consists of architecture guidance, as well as a reference implementation that is aligned to principles of what we call the Well-Architected Framework, as well as the 12-factor application methodology. So these things will really enable you guys to really modernize those large mission-critical workloads on Azure in a reliable, secure, high-performance, cost-efficient manner using best practices that have been vetted by Microsoft directly. And the first pattern that was delivered through this initiative was called the reliable web app pattern. And so this pattern is specifically geared towards those line of business applications that are on-prem looking to go out to the cloud. It's really that customer's desire to converge on the cloud. And of course, making sure that we, kind of try to target those on-premise line of business apps that really we want to be able to try to make sure we have minimal code changes to. Every single code base is different, so we have to, of course, review those. But the idea is if you have some of these very standard monolithic line of business applications that have web apps, perhaps they have an API backend as well as a SQL Server backend, this pattern will be something that will be very familiar to you. Let's go ahead and click the next. And we took, into account the need for differing environment cost profiles. So we have cost profiles for production as well as development. We defined SLA and SLO requirements and measurements, also addressed DevOps processes for multiple configurations, and used the latest runtime versions and of course our modern tooling included as well to support the customer's journey. We were also able to implement all of this desired functionality and capabilities to address the customer and field feedback, people from our own internal groups. So let's talk about some of the different pillars that we really kind of wanted to address from this design standpoint. So from reliability, we added infrastructure and coding best practices and patterns to ensure the application is resilient and handles those failures gracefully. Patterns such as retry, circuit breaker, these are implemented within the provider reference architecture that we'll get into in a moment. From a security standpoint, the application uses modern authentication and authorization and managed identities for inter-service communication. Dependencies like Redis, Key Vault, SQL, all of these are only accessible through private endpoints within the VNets for a security standpoint. Cost optimization, our Bicep and our and we're also building out Terraform templates are designed for both for provisioning both the development as well as production workloads, where all the services are right sized for their intended environment. And we also use a new tool called the Azure Developer CLI, also known as AZD, that enables developers to quickly provision and tear down their environments and save those costs. From operational excellence, the Azure Developer CLI also provides GitHub Actions as well as Azure DevOps pipeline configurations to quickly enable CI/CD setup and execution. And because we have defined our environment using infrastructure as code, we enable repeatability and consistency through that automation. We also address observability through the use of Azure Monitor and application insights. And finally, from a performance efficiency standpoint, we have built-in on-demand scalability by utilizing the appropriate compute tiers and sizes and service-specific scale rules that meet application capacity demand based on those different environments. And of course, all of this is built on top of the pillars defined within the Azure Well-Architected Framework and that 12-factor application methodology. So this is the actual .NET architecture solution diagram that we built out. You'll notice that it is a multi-region deployment for our production-based implementations. We did that so that we could have that high availability for our mission-critical applications. And you can see a lot of the different services that we have made decisions on, including such as our Microsoft Entra ID, which was formerly Azure Active Directory, as well as our front door for security and content delivery. We have configuration in our app configuration and our Key Vault, which of course it gives us our centralized configuration and that secret management. We have app service as the main compute platform, and we also have Azure Cache for Redis, storage accounts, and the Azure SQL database, all secured through those private endpoints. Now, this is a typical scenario of a monolithic line of business .NET application with at least a web tier and an API layer, as well as a database. And in support of migrating to the cloud, the team focused on reliability and added the necessary Azure services to meet the defined SLOs and that are defined within the actual pattern guidance, which we'll show you in a bit. We've included security best practices like managed identity and Key Vault, and reliability best practices such as the retry and circuit breaker patterns. This implementation includes additional features like integration with Entra ID, securing services to private endpoints, centralized configuration, using app configuration, and securing secrets with Key Vault, and more. So with that, I will jump into some of the demos, and we'll start looking at more of the fun and interesting code stuff. Let's get some sharing going. So Let's talk about what's available to you guys as customers. So with this first pattern from our EAP initiative, we did provide this guidance publicly through our Azure Architecture Center. This is the link in the website to the different guidance, as well as some details about the implementations. We do have a .NET as well as a Java version. We'll be focusing in on the .NET one. But as we look at this guidance, which is available to you, you'll see some of the same things that we're showing, individual items about the business context, the principles, and how we implemented this stuff. And of course, this whole thing will then point you to ultimately the repository that sits out in GitHub that is available for you to clone and even contribute to. So let's talk about the guidance out here in GitHub. So we've provided this guidance directly from within the READMEs here. We talk about our guidance, the architecture. We have a set of videos that have been also filmed for your review as well. But really, what I want to talk about here is really kind of how would you, as the customer, be able to stand up this pattern for your own edification, for your own learning and testing. And so we have some support for, of course, doing this within dev containers. But I'm going to talk about what you would need on your machine to be able to get it up and running locally for your own development. So prerequisite-wise, we, of course, need Git. We need the Azure CLI. We also need Bicep, which is an extension of the Azure CLI, as well as that new tool called the Azure Dev CLI. And we'll talk a little bit more about how to use that. The reference architecture uses .NET 6.0. So make sure you also have that runtime as well. And just high level, because we don't have time to do the deployment or the provisioning and the deployment, because it does take about 25 minutes or so. But we're just going to go through the steps so you kind of understand how to get this up and running within your own environment. So quickly to talk about this, and then we'll dive into what the results or the output of what these commands will do. We need to define our environment name as well as initialize our environment within Azure or AZD. We need to make decisions on whether or not we're going to have a development or a production configuration. By default, we use the development one, but if you want to use a production configuration, which is a multi-region configuration, you will set isProd to true. You can also set your secondary region to be in a different data center, in a different geographical location. And then the last command will just be using the AZD provision. This will kick off the Bicep template and automatically set up your environment and run all the different resources and modules from within that template. I'll show you the output there. Once that is done, we have to then register our two applications, our web as well as our API application with Entra ID by using app registrations. So this is a separate script that you can use. You'll have to have elevated permissions to be able to do this in your environment. Just be aware of that. And the final step would then be, how do we deploy the code, the reference architecture that is provided as part of this pattern? Of course, here we just have a simple command to be able to make sure we are targeting the right resource group, and we do an AZD deploy from there. Once that's done, you'll have a fully set up environment that will then, of course, show you a website called ReliCloud. The business context for this reference architecture is that ReliCloud is a company that sells concert tickets, and you can call in to agents or call center agents and then ask for the different concerts that are available, provide your credit card information, they will purchase the tickets and send you the ticket information for your consumption. So this application was an on-prem application. It was developed against Active Directory internally. And so when we moved this out, we had to, of course, make sure this was deployed to Entra ID. And so only employees of the company called ReliCloud can access this website. This is the phase one, by the way. Some of the nice things about AZD while we're at it is that when you stand up your environment and you do a AZD provision, you can quickly, of course, bring it down. This is a nice command to be able to clean up all those resources so you don't get yelled at by your management and admins that you are using too many resources. We also have some support and guidance around local development. So if I was to be able to access this environment and do some work locally against those different resources, we provide that guidance for you as well. The last thing to talk about, and this is for more of a training purposes, but we have the idea of what we call simulations. And I'm not going to show you all the simulations. I'm going to show you some of the results of some of them. But this is great for you as far as understanding the things that we added to this pattern. So I will show you some of the code and some of the different resources that we use to support the WAF pillars that I mentioned before. But if you wanted to kind of dive into how to kind of exercise those different capabilities within the reference architecture, we have a simulating patterns area where we can test out the retry pattern, the circuit breaker pattern, as well as the cache aside pattern here as well. With that, let's dive over to what was created. So let's assume 25 minutes has passed, and this is my list of resource groups in my local, my personal subscription, and I chose a production deployment. So I have two different resource groups that have copies of the same exact resources in each. And just to prove that, if I click on each one, they all have the same resources. They're all behind the Azure front door, or the front door resource itself, and that failover, of course, will take place between these two different regions. So let me sort this. Talk a little bit about the resources. I'm going to go back just to give a quick refresher on the pattern, so we can talk about the resources. If I jump up to here, excuse me. So we're going to look at one region, and some of the things I want to make sure we're going to talk about. We're going to talk about the security. So we're going to go over kind of the VNet and the subnet structure that I'll show you inside of the Azure portal. We'll talk about the private endpoints for gaining access to our dependencies outside of the VNet. We'll also talk about our managed identities, which gives us access to these different resources as opposed to storing connection strings within configuration stores. And so let's go take a look at that. So I'm going to just quickly jump through here. We'll try to minimize some things, make this a little bit easier to read. But as you'll see, as I scroll down here, we have our app configuration, which is our centralized configuration store. We have our app service and our plans that will be hosting the web and API services. We have our application insights, which will be collecting telemetry from both of those different services. And then we have our Redis cache dependency. We have a couple of deployment scripts that are left over from our deployment or our provisioning, which will eventually clean themselves up. And we have, of course, some of the details around our key vault, our front door, and then we dive into some of our security side of things, which are our managed identities being used, as well as our network interfaces, our security groups, our DNS, and our private endpoints themselves. And ultimately, we have, of course, our SQL Server for our data storage, and then our virtual network. So let's dive into some of the key pieces of this overall deployment, this provisioning. And then we'll dive a little further into some of the different patterns themselves. So one thing I wanted to make sure you're aware, I called it out when we were looking through the steps. The application registrations is a required step that is necessary to make this work. And this is usually a highly sensitive area that developers usually don't have direct access to it unless they have their own private subscription like I do. But essentially, when we dive into one of these, we can also see things like our support for our local development. So if I'm running this locally on my local host, I have that URI registered, as well as my configuration for front door here as well. So let's dive a little bit into the virtual network. So I mentioned, and you saw in the solution diagram, that we have configured 3 different subnets. So we have a subnet for each of our different services for our web as well as our API. And these are also delegated only to our app service itself. But we also have a third one, which is what hosts our different private endpoints. And so any of our access to our external dependencies will happen through this subnet here. Keeping on the security front, the other thing is this is the API web app. itself. And I just wanted to point out the use of a user-assigned managed identity. So as the API will need access to things like Redis cache, as well as SQL Server to be able to grab the data necessary to feed back to the front end. And we don't want to, of course, store any kind of connection strings or username and passwords. So we are taking advantage of a best practice of using what are called managed identities. We're using a user-assigned one, which means we can share it across multiple resources. And then we use RBAC to be able to provide access to those resources to this specific entity itself. From a configuration management, we do have a key vault that is storing currently 2 of our secrets, which is our client secret from our Azure AD or from our Entra ID. We also, though, need to have a connection string directly to our Redis cache, so that is one we do need to have a connection string for. Jumping over to app configuration, if you're not familiar with app configuration, it is a centralized application configuration management store that also has some other features around flagging, feature flagging mechanisms, etc. But the nice thing about it is that not only can you have centralized management of configuration values, but you also have integration directly with Key Vault itself. So you can see we have access directly to those 2 secrets through app configuration. And if I go to the identity here, actually that's not what I wanted to see. Let's go back to our configuration store. So just to know that these have access to our key value store over in Key Vault, giving us one place to be able to hit for configuration, but being able to pull out those secrets from that specialized secret store. And this is Azure Redis Cache. I was going to show you this. This should be something similar to the other dependencies, but right now we wanted to make sure our Redis cache is not accessible publicly, but only directly through the VNet through our private endpoints. And so here is an example of how we go down to our configuration for private endpoint, and we then have configured this resource to be able to use this private endpoint, which relates to an IP address within that subnet I was showing you, to gain access to this resource and the data stored within. So let's dive over to kind of what did we deploy? We just looked at the overall deployment itself and some of the different resources within that deployment, but what exactly did we deploy? This is the application, the reference architecture that we're using. It's straightforward. So we do have the ability to log in as a employee. So this is the integration with our Entra ID. And then we then, of course, can dive into the different concepts that are available. Of course, we can search them. And if I wanted to be able to then add one to a cart, in this case, someone's on the phone with me because I'm an agent and I'm getting information from them. Let's go add 8 tickets for the Finn Anderson concert. We'll confirm it, check out. We'll use this, run a purchase. And that purchase will automatically purchase those tickets. It'll also generate barcodes that are stored within the blob storage that we can then, of course, send off to our customers that were on the phone, and then they can print those out for admittance into the theater of choice for that concert is. So now, what exactly, what I want to talk about now is I want to talk about a little bit about the idea of the patterns themselves, the resiliency patterns, the reason why we call this the reliable web app pattern. And so what I'm first going to do is I'm going to dive into some of the code to talk about this. Before I do that, I want to kind of talk a little bit about, actually, you know what, I'll stop. I'm going to go back into this after I finish with the code. So let's dive into some of the code, and I'm going to dive over here directly into first the infra, and then we'll jump into the individual reference architecture and some of those different items. So the bicep template that we created is a very modular template, which we have many different bicep files that are going to be housing the different resources and dependencies necessary for those parts of this template. So we can see our different bicep modules for configuring front door, our key vault, our Redis cache, SQL, etc. But the entry point into this is going to be our main.bicep file. And if we take a look at the main.bicep file, I'll get this a little smaller over here. We're doing a lot of bootstrapping. on this environment. So we're setting things up like our log analytics workspace. We're creating all the different resource groups themselves. We're provisioning out some identities necessary for running the individual deployment scripts that we're going to be having here as well. But the two pieces that we really want to call out are where the main heavy lifting is happening, which is in the resources.bicep. And we have two lines. We have one for our primary region, and we have a secondary region over here, only if we are set up for multi-location deployment. Because, like I mentioned before, this environment that I just shown you, we did do isprod equal to true, so that means it would run this resources.bicep again, passing in those secondary configuration and parameters necessary to configure the second environment. Let's dive into the resources. So, of course, we accept our parameters. We do some work around our role assignment. So we need to make sure that things like our the interactive user, which was the person, myself, that is deploying it, has certain ability to gain access to resources, but also our managed identities also have the appropriate access as well. And then we dive down here, we'll see a few things that are familiar. We can see where we're setting up our websites or our app service plans. We have also places where we're setting up app insights, et cetera. We will see these modules being called out to be able to call the individual bicep files from there. The nice thing about this template is because it's so modular that you as customers, you might say, well, my application is not exactly like the reference architecture, and I need to add or remove different items for support of my particular solution. And so that's what's so nice is that you can go ahead and pick and choose the different things that you do want. And of course, you can add your own different bicep templates and modules to be able to support your use cases. With that being said, I'm going to close that up. We'll talk a little bit also about inside of our folder here. We have a handful of different scripts. This will be more for your discovery if you guys go out to the repository and start looking around. We have some scripts that are used for being able to manage the deployment itself. These are run as what we call deployment scripts under the context of a managed identity. We also have scripts that are there to support DevOps. As I mentioned initially, that we do have support for GitHub Actions as well as Azure DevOps. And if you are going to be setting up local development and make sure you have access to things like SQL from your local machine, you'll need to be able to run a handful of scripts to be able to add those firewall rules, et cetera. So that's from an infrastructure standpoint. From a source standpoint, we have our source code, which is just our .NET reference implementation. And here I want to talk about the resiliency pieces, the minimal code changes that were necessary to get this from on-prem out into the cloud and to ensure that we have that support for kind of, the cloud has a little bit more of that disparate feel and that has the ability to, of course, introduce more occurrences of transient errors. And how do we make sure that our application is as resilient as possible in that kind of environment? We mentioned the retry policies, and we mentioned the circuit breaker policies and the cache aside pattern. Here I am over in the web application. So this is the front end application, and they are registering a handful of what are called named HTTP clients. And we are then, if you can see on line 85 and 86, we're using a library called Poly to be able to define our policies as well as be able to attach them directly onto our named HTTP clients. And so these are the two policies that we're going to share across all the different services that use HTTP. And that means that every one of those different services will then, of course, be able to then recognize transient faults and then, of course, to apply the logic and configuration based on these two different policies. Let's jump over to the API and we'll talk a little bit about what patterns we've used over here. So the first one I wanted to go through is, yes, this is the one. So this is our add concert context services. The API does use a library called Entity Framework. And Entity Framework is an ORM tool that is used to be able to connect to different types of databases using more code semantics for that access. And when we configure Entity Framework to be able to connect to our database, we have some configuration, as you can see here on line 111, where we can define enable retry on failure, so that if we do have any of these transient failures when connecting directly to the SQL Server, the Azure SQL Server database itself, there are certain configuration values we can assign to how it does retry for that database connection as well. When it comes to our distributed, we talked about the cache aside pattern. Here is our registration for our Stack Exchange for Redis cache, and the ability, of course, to then now set up caching and inject that caching object directly into our code for usage. And then for support of the simulations themselves, for you folks, when you decide to go and try to test out these different patterns on how you can see how the app reacts, maybe take a look at some of the different telemetry that's being logged around the behavior. We have this line 168, which is just a middleware that we inject to be able to kind of drive the failures themselves and how we want to be able to see those failures. We use a specific configuration value called the retry demo. And if I jump back over to my API and jump into configuration, you'll see that I have set this up already. The application for our demos was running just fine, as you noticed, but I did set it up to fail every other time. So when you set it to a value of 2, the first time will succeed, the second time will fail. Every 2 requests automatically fail. So the application was running just fine, but it was doing retries, and we'll show you some of the output for that. And this is just something you would never have in your production application. This is strictly there. I wanted to point out strictly there just to be able to exercise those different simulations. So with that being said, that's kind of the anatomy of the reference architecture from a coding standpoint, as well as from our infrastructure template standpoint. Things to call out here is we do have the different pipeline configurations for, in this case, Azure DevOps. We have also the ones for our GitHub Azure actions. We have support for dev container. So as I showed you, those different prerequisites of the AZ CLI, the AZD CLI, et cetera, all of those are also things that we have containerized and can be used directly from a local Docker image that's running locally. And then, of course, you can do that so you don't have to install all these if you have any kind of restrictions from your organization. All right, so that's the thing. Let's just jump back into the last bit of this, which is going to be, I talked about that. Yes, all that. Last thing, of course, is going to be our monitoring, our configuration. So we have telemetry that is being fed into an application insights in resource, which then, of course, gets fed into a log analytics workspace for centralized logging and reporting. And as you can see here, we're just showing that when I was running this application, the application was running just fine. Maybe there was a little bit of latency because of those retries, but you as an end user saw no significant impact on the usage of that. But you can see from the API's reporting, there are a certain percentage of failures due to that setting that I turned on to be able to simulate those different errors and kick off those retries. So if we were to dive into these different instances, we should be able to go and see some of those individual issues. I think I was trying this right before the call, and Application Insights was not being happy with me. So I'm not going to try to dive into it, but essentially, if you were to look at the telemetry, you would see from a request down, well, I have time. Let me just do that real fast. Maybe it's working. Let's go to transaction search. We'll dive into the refresh. If I see these 3 dots for more than 10 seconds, we're going to cancel this. Yeah, it doesn't look like it's recovering. So anyways, we're gonna skip that. I was hoping to be able to dive into the individual telemetry items. The nice thing, if you haven't seen Application Insights, when you when we log a request for a hit on an endpoint or a route within a web application, that will get logged into Application Insights, and all of the dependencies that are associated with that request will also get logged. So then we can see things like our HTTP request over to a specific service, like our API. We'll be able to see dependency calls, like calls to SQL Server or calls to Redis Cache, and we'll get to see all that in a timeline fashion, which is really nice. But it doesn't look like App Insights is going to be cooperating today. I'm going to stop sharing here. We're going to go back to sharing the slide, and we're going to fission up, and then we're going to go into some Q&A.
Yeah, we have 2 questions in the Q&A to cover.
Okay, fantastic. Let's resume where we were before. All right. First things first, how do I get this? This is the .NET version of the pattern, but I wanted to make sure you also realized that we have a a Java one as well. So I added that URI, or just that short URL as well. Please go out and clone the repository. If you want to be a contributor, we have other customers that have been adding in issues. If you really get amped about the pattern, please fork it, create changes, generate pull requests, and folks on the call like Adrian and others will be able to then review those, and maybe that feedback and that contribution will make it into this pattern or one of our future patterns for that matter. And with that, I'm going to be ending this, saying thank you, and we're going to dive into Q&A. So I'm going to jump over. Derek, do you want to how are we going to do the questions? We're going to go ahead, and are they in the chat, or do we need to just get people off of mute and start talking?
They're in the QA section, so there's 2 questions from in the QA.
Oh, there's the QA section.
Yeah.
Gotcha. Okay, let's take a look here. Can we talk about logging a bit? In general, I found logs are slow, take 30 seconds, minutes, show up in there. Yes, they do. So there's this concept of sampling, and that sampling is something that has a default value within your application, and of course you can then fine-tune that sampling. But in general, there is a certain amount of time for the ingestion of that content, and then of course the ability to have it then move through that App Insights into maybe a common log analytics workspace. The thing that you can use is a thing called live metrics. So if you wanted to see more of a real-time view of what's happening, if you jump over to live metrics, that will connect to the resource and then show you some of those things that are happening pretty much almost in real time. And then you can kind of diagnose some of the issues using that feature of App Insights. And does hot reload of the app configuration work reliable in applications where app configuration, or are there any gotchas? So hot configuration is something that you would have to configure within your application itself. So we have the ability to basically have this concept of options. When I make changes to a local configuration, might be the app configuration.json file. The answer is that there are ways for you to configure it to be able to be responsive enough for your needs. You just need to have that configuration within the application. So the application needs to be smart enough to go out and try to get that new data. Then how does DB replication work for this across regions if this is an active deployment behind front door? I'm going to try to defer this to Adrian. Do you have more details around the database replication side of this?
Adrian did answer it.
Yeah, I did. I did answer it, but just to verbalize what I typed, the implementation that we have is an active passive where one region is active at any given time, and there is a failover process. That was to balance the requirements of cost optimization with the SLO or RPO recovery point objective and time that was needed. You can absolutely do active. It just requires a little bit more, not only in terms of database replication, but file replication and making sure that the caching is updated. So there's a lot more to replication than just the database piece, which we didn't do because we were active passive for our applications.
Thank you, Adrian. Anyone else? Any other questions that we can address before? All right. So one thing I wanted to point out, we have folks that are on my team. We have Derek and we have Tom and we have other folks that are part of the application innovation technical specialist team and group. But the key of being able to show this pattern to you is that if you have applications that are on-prem, that are monolithic in nature, that are your standard line of business apps that follow this familiar pattern here that we just showed you, then we really want to engage with you around proof of concepts, to be able to say, here's how we would take your solution and use these patterns to be able to then bootstrap and accelerate that move to the cloud if you're looking to get your applications out to the cloud. I just came from a customer over in Denver, Colorado, who was looking to do the same thing. Within 2 or 3 days, we had an application up and running, and they, this would have, of course, taken weeks for them to be able to better understand, the concepts behind the security on managed identities, private endpoints, of course, and the tooling itself, right? The idea of how do developers now moving into the cloud, needing to support applications in the cloud, what kind of tools are available to them, and their fast start on using that new tool that we have through Microsoft called the Azure Developer CLI as well. So we would love to engage with you. So please get with your specialist, any of your Microsoft account team, and we would love to chat with you more about how to use these patterns to help drive your convergence to the cloud. And with that, I think we're all done. Derek, what do you want to do?
If there's no more questions, thanks for everyone attending today. We'll make sure that we'll get this recording posted of the session. So if you ever want to watch it again, or somebody somebody that wasn't able to attend, you can pass the link along to them to be able to view it. We're also looking at having a few more sessions before the end of the year on this Azure enablement sessions. And then starting next calendar year, we hope to do this on a weekly basis. So look for those invites coming along, and hope to see you on future sessions.
Thank you, everybody. Appreciate it.
Take care, everyone.
Thank you, team.
And thanks, Adrian, Nish, and John for joining. Appreciate it.
Thanks a lot, guys.
Thanks, everyone.
All right. Bye-bye.